So you're being told that this function here is the derivative. And then you're being told that q of 0 is 7. In simple words, if you do the antiderivative within the function q of t, there is a point 0, 7 that is on that curve. That being said, big Q of t is the original function of the derivative, which is little q of t. Therefore, big Q of t is the integral of all of that. Finding the integral of sine t is going to be easy, but the second half will not. The Q of t integral 5 sine dt minus integral 3 1 minus t squared dt. So then I'm going to take out the 5. Now, let's just talk about this part. Do you remember what the integral of sine t is? Negative cosine. So, just for the first half, mind you, we have 5 times negative cosine t. Recall. Obviously, what I'm going to do here is bring the 3 outside. And then, what I've got is a carbon copy of the one that we have on the right. Well, which means minus 3. And then what I have, well, let's see, that becomes a inverse sine. My u, in this case, my u is t. What's my a? Well, in this case, my a is 1, because 1 squared is just 1. Close that, and then, of course, plus c. Now, I've got a little housekeeping to do here. So this becomes minus 5 cosine t, and this becomes minus 3 inverse sine of just t plus c. Now we use the point that we were given as reference, which of course is 0, 7. 7 is what? It's my y value. Put it here. Negative 5 cosine 0 minus 3 inverse sine of 0 plus c. What's cosine of 0? It's 1. So here with the sine, you're being asked what angle has a sine value of 0. This whole thing is 0, which means that entire middle term disappears. And you end up with 7 is equal to negative 5 plus c. Well, if you move 5 to the other side, c becomes 12. Then your complete overall function is negative 5 cosine t minus 3 inverse sine of t plus 12.